still waiting on Barney to join in. I sent him an email just reminding him to call in. I am not. I don't see him called in just yet. There's still 1 minute, I guess. So
You can absolutely wait for him.
So now, if Barney doesn't call in, does that mean BACnet wins?
that it would seem like it. It would seem like that.
So Barney has joined us. So I think that puts us at a full quorum here. His audio should connect momentarily.
Awesome. Barney, can you hear us? And I assume Steve, Joseph, you can hear me as well, right? So we can get going.
We've got
I
you.
hear you. Can you hear me?
Yes.
Okay.
Awesome.
And back,
We are all set. Okay, so just kicking this off. So thank you so much for participating on this panel. So we're going to be talking about security and monitoring. And primarily the focus of today's panel is to sort of bring a collection of representation from the industry, from number one, consumers of
Yes.
monitoring systems such as ourselves, which is Google as well as Facebook. Second would be representatives from the HVAC space, and Joseph is going to introduce himself, and finally representatives from the electrical space, and Barney is going to introduce himself as well. So hopefully it should be an informative and illuminating conversation. So with that, I'll turn it over to the panelists to introduce themselves.
I'll go. Steve Scott.
Barney, you want to go first?
Oh, go ahead.
Oh. Go for it, Steve.
Steve Scott. I am a data center InfoSec engineer. And I will admit that I've got a much stronger IT security background, and I've been kind of dabbling in the OT ICS side of things for about the last 6 months. So I would admit that I have now seen the light. So I came from a perspective of, as an IT security practitioner, why can I not run a vulnerability scan against these industrial control systems components? And now that I've been actively engaged in it, I have a much better appreciation of why we can't do these things, and have really feel like I've been enlightened. And so I really like to point out that there's a significant difference between the IT world and the ICS/OT world, and really happy to be here. I'll pass it to Barney.
Barney, I think you might be muted.
Looks like Barney's audio may have dropped. Barney, you are muted here.
I believe I'm here. Can you hear me?
Yes, we can. Thank you, sir.
Sorry, I was having a technical moment. My name is Barney Keaton. I'm a global solutions architect with Schneider Electric. And we are currently supporting Facebook.
I'll go next. This is Joe Klotz. I'm with Johnson Controls. My title is Business Development Manager. Our focus on building automation systems, building management systems. We work with a large variety of data centers and data center consumers. And my focus is around the systems that control the spaces.
Great. Thanks, Joseph. Thanks, Barney. Thanks, Steve. And I'm Anand Ramesh, and I work in an organization called Advanced Technology and Innovations in the Google data center vertical. So I've been at Google for a total of roughly 12 years in various roles in infrastructure. So with that, so the topics we'll cover today are, number one, securing controllers and facilities networks, and then unifying communication protocols across various hardware types in the data center. Looking at the value of standardizing data formats across different vendors and equipment types, and also updating equipment in the field. So without sort of further ado, I want to sort of start with the first question around protocol uniformity. So typically, building automation systems, that's basically HVAC, and power systems use different protocols. So BACnet is sort of the favorite on the HVAC side, and Modbus is kind of the standard for power systems. So is there value in standardizing to a single protocol for ease of integration so that when we are commissioning and deploying data centers, it becomes more seamless? And if not, are there sort of trends in the industry to unify around one protocol for each use case? So Steve, do you want to sort of give us at least the viewpoint from Facebook as a customer or a consumer?
Sure, absolutely. And as I mentioned, coming from the IT background and being immersed in this ICS world, it's confusing. So many different protocols and different things that need to be monitored. So from our perspective, absolutely, trying to get down to at least one or at least fewer different protocols for us to monitor and understand would certainly be helpful. Barney, what do you think about that?
Yes. So from two aspects to that. One, you've got internal communication protocols that are used within the control systems, and the second being the protocols that are used to make data available to DSIM, traditional DSIM. And today, certainly around the security aspects of the DSIM side of it, OPCUA provides the certificate, all of that security aspect that's looked for on that side. In addition, I would say that the other traditional protocols, BACnet, Modbus, both are offering secure communications, encrypted communications, etc.
So this is Joe. Barney brings up some good points, and there really has been a very fast evolution of these protocols in the last 5 years. In fact, the ASHRAE BACnet protocol 1 year ago introduced something called BACnet Secure Connect, which introduced the use of TLS, HTTPS, encryption, IPv6 all built into it. But like you've said from the start, there's a lot of components going in: meters, PDUs, crack units, the HVAC equipment, boxes, and trying to bring that all together is a challenge. The other thing that Barney brought up is one of the unifiers could be OPCUA, and most of the manufacturers of building management systems, they do support it through a BACnet OPCUA type interface. So I think that there's challenges there, but there's plenty. Is there a single protocol? I don't see one right now. I mean, OPCUA could be the one that unifies it. That's unified architecture. Hey, that might work. Over to you, Steve.
Well, and I was going to ask about OPCUA, but something else struck me. Just thinking about encrypting these protocols, what are the upsides and the downsides to doing that?
Well, encryption, we start talking about security certificates and who's managing those certificates, and that starts to become pretty sticky. So that might be one aspect of it right there.
Yeah, I would agree with certificate management is a long-term investment. It definitely requires analysis regarding the expiration of certificates. So,
And
we've got.
sorry,
Go ahead.
I mentioned, coming from that IT background into the OT background, and in IT, it's like, well, encrypt, let's encrypt everything, why not? But understanding now the timing requirements for these systems, and understanding that adding encryption obviously adds a little bit of overhead, and I have a better understanding now of why you might or might not want to encrypt this kind of traffic.
So trying to be a little provocative here, right? So there was this very well publicized hack of a Jeep Wrangler several years ago using, sort of vector with the LTE link into the car. And, the hackers essentially proved that they could take control of the vehicle steering and braking systems. So now even the automotive industry is talking about encrypting things like CAN bus, right? The payloads over CAN bus, which is pretty lightweight, and there are very, very stringent timing requirements. So just trying to be provocative here, if the automotive industry can consider encrypting things like CAN bus, why wouldn't the industrial controls industry actually think about encrypting payloads for things like power equipment and cooling?
Well, I think one of the things that Steve brought up is the timing issues. When you're starting to do real fault detection diagnostics of power systems, you want to make sure you have a well synchronized timing system. And if you're introducing some additional times because of encryption, decryption, that might be one of the challenges right there.
yeah, and I would say that when you have multi-layered networks involved with these types of systems and industrial controls finding its way into these systems, you definitely need to consider physical protection of the system, as well as the depth and layers approach, and encryption. At what layer encryptions becomes active within that approach is certainly something that needs to be looked at.
Okay, so OPC UA might be the sort of way by which all of these different factors which are relevant, including security as well as uniformity, might converge. But it does seem like the two sort of industry verticals are definitely going to stand their ground for a little bit, right?
I think there is a lot invested on both sides, on whether it's Modbus or whether it's BACnet, a tremendous amount on both sides. And as you led off, two different sides of the industry that unite themselves in data centers between the power equipment, the lighting, motor control centers, PDUs, versus the HVAC equipment and the control of the equipment.
Got it. Okay, so moving on to talk about a little bit more with the security bent. So, how are equipment vendors such as yourselves thinking about securing your controllers like PLCs, microcontrollers, or even larger scale control computers? And what is the evolution towards security with some of these commonly available protocols look like? I know we covered a little bit of this in the previous section. But I want to sort of, give the panelists the space to kind of expand on this a little bit more. So, Steve, do you want to sort of at least look at, what again as the sort of end customer, putting your Facebook hat on, how you're kind of looking at this?
Sure, and one of the things that we've seen is a lot of this equipment coming in has extraneous stuff, what we consider extraneous stuff attached. So, you know, do I need a circuit breaker that has NFC enabled? From our perspective, any extraneous network connection adds a security concern. So, you know, one of our requests would be let's you know, strip this stuff down. Just because we've got a new technology and it's neat, is it helpful or does it actually hurt us from a security perspective? We like to think that simpler is better. So just curious what you know, the manufacturers, how they're looking at this and considering what kinds of extra components they add to their equipment.
So I'll take the first stab at this. From a controller perspective, and that controller being what is in charge of the process and making sure that cooling is provided to the data center. That controller can have all of its features essentially turned on and off. And from that perspective, and also that there are add-on components that are not part of the base product. For example, Wi-Fi. We would, you know, not include those in the solution for the data center environment where IT has these restrictions. From a breaker perspective, or like a drive, certainly the industry is leaning towards smarter wireless connected devices, many of them coming with Bluetooth possibilities. All that I'm aware of, these are also able to be disabled, perhaps not removed from a component perspective, but certainly disabled.
I think, again, Barney touched on some interesting ones. We like to see it in our industry, like we're adding some value to it, you know, and Steve calls it extraneous stuff. We look at it as, oh, maybe this will help sell it. We see a lot of vendors promoting Wi-Fi, but then when I go to a customer site, whether it's a large university or military installation, you know, Wi-Fi is something they definitely don't want to see. And as Barney said, maybe it's there for configuration, troubleshooting, but you have to turn it off. You have to have the ability to turn it off. Same thing with Bluetooth or Zigbee, some of these other wireless protocols out there. But that still puts it back to the physical aspect of security. If somebody can turn it on or off, that means how do you limit that capability? This idea of over the network communications, BACnet was created to be extremely open, and by its nature was extremely unsecure. I could literally walk into many buildings today, hook up my notebook, plug it into the network, and with a simple auto discovery feature that's required in BACnet, go out and get into every controller that's out there. And then I can turn things on and off, modify set points. So that was the reason for this next version, BACnet Secure Connect, so that you would see now this exchange of security certificates. A lot of our military applications are talking about wanting to apply their own security certificates, their own private certificates, and not using just the public certificates, because some of those certificates are already breached and open. The other part I think we touched on a little bit when we did some prep work was the Federal Information Protection Standard, Fips 140-2. The military now requires this for an additional network and data level. So this is something that's getting built directly into the BMS controllers. So between the BACnet SC side of things, Secure Connect, and Fips 140, it starts really elevating us into, if you want to call it, military grade security capabilities.
And Joe, you've touched on some of that encryption that's being built in, and just wondering about kind of lower level stuff and how you guys are thinking about this. So how about addressing secure boot? Ensuring that the firmware that's installed is what was intended to have been installed.
No, that's an evolution that's happened too. I would say most of the manufacturers out there have reconfigured their IP-based network level controllers as a minimum to have a secure boot capability. And a lot of us are going to at least two-factor, if not multiple factor authentication. The other aspect that I think that keeps coming back is the physical side of it. And for example, military applications require something called a risk management framework, which goes through every component. Now that's quickly shifting over to a new requirement that says, I want to look at the individual components that go into your controllers. I want to look at how and where you manufacture them, who's involved in the manufacturing, who's involved in the configuration, programming, installation, and touching the user interface. And so now for military bases, there's going to be a much wider variety of things that are required before you can even get started on a project there.
Yeah, I would also offer that the PLC being the product that has certainly been subject of movies, that also firmware, signing of firmware, verification of the source of the firmware within the controller itself on boot is critical, as well as deploying controllers to a facility. Those controllers need to go through a verified, validated process before they are installed at the site. In many cases, firmware versions and hardware configurations are pen tested in order to assure their lack of vulnerability in the installation. And those processes, in many cases, when you're in a hyperscale deployment of data centers, where you've got anywhere from 500 or 600 data halls being built over a 3 or 4 year period, when you're in that environment, it's most critical to lock down on a pen tested version of hardware and firmware and ensure that deployment is able to meet the rapid schedules required as well as the security requirements.
Great. So it certainly appears that the industry is sort of evolving and it's thinking towards securing some of these controllers. So while we're on the topic of security, I want to sort of pose another question, which is around over-the-air updates. So we all know that software requires periodic updating, but at least in the sort of PLC space, we have kind of tended to deploy hardware and frozen for long periods of time the firmware or the control code, if you will, that actually runs these devices. So with network connectivity, we may have the opportunity to actually update some of these devices or this hardware over the air. So I sort of want to again pose this question first to Steve from Facebook's perspective, or at least a customer like Facebook's perspective. Is this desirable, and is this something that a customer like yourselves would embrace? And then I'd love to get Barney and Joseph's sort of perspective on the likelihood of something like this happening.
I think it is something that we would embrace, but we have to take a much different approach to it, as opposed to Microsoft Patch Tuesday. We don't want to be patching these systems every week or every month. For us, kind of shifting from that the standard security triad of confidentiality, integrity, and availability, really have to change the mindset for for the OT world to where safety is at the top of that triangle. And, you know, some of this stuff does include life safety concerns, and applying patches, you have to have a very robust program for testing it, rolling it out, and ensuring that there aren't any, you know, bad fallout events when you do apply these patches over the air. I'm curious to see what what Barney and Joe think about the ability to do that.
So I'll take it first this time. I think that firmware and a PLC, there are several cases that lead to firmware evolution. Many of those, or I would say the majority of those, are inclusion of new features into the product. And if you're not going to utilize those new features, then you don't need that new firmware. In the case of fixes, either to bugs or to close vulnerabilities, if the system is modular in nature, like a PLC is, there is a better opportunity to update the firmware without having to shut the system down, nor without and providing that opportunity to test and validate the changes that you're implementing. Another key feature needed in order to ensure that you're not going to take the facility down in order just to update firmware, and you're not maybe if you're at an N+1 design configuration, you can tolerate one system going down and still meet your load demands. But if you deploy a hot standby system into that, then you have the opportunity to update the standby controller while the primary controller is doing its business, flip it over and do the other. So that is in my opinion, a critical design feature that needs to be included into these systems if, in fact, you are going to have to evolve due to cyber vulnerabilities over time.
So I get involved with a lot of the large centers out there, a lot of large data centers out there for the big names, and I find it curious that they have plans, whether it's a Tuesday patch, but they have plans already established on how they're going to take care of their servers. But it doesn't seem that they thought it through in terms of the HVAC equipment and the PLCs and how they're going to do that so much. That doesn't seem. Barney brings up the great points that, you know, either you have a complete test bed where you can test out patches, you can test out beforehand, or of course having, you know, the N+1 or the hot redundant capabilities built in. So I think that's a critical thing. But it is curious, of a lot of our customers out there, data centers seem to be the slowest to really keep things moving in the right direction. So they might have revs that go back 3 or 4 or 5 revs, and they have not implemented any of the patches to them. So I think that's something that needs to be reviewed. And now that more and more our IP connected devices, it becomes more important. For example, in the past, we would have a network level controller that sat, and it was an IP device. And then downstream of it, you had the smaller equipment controllers for small VAV boxes or fan coil units, and they were all off an RS-45 bus. So they weren't of any concern, and you couldn't see them either. Now all of those controllers are evolving into the IP world. So for example, a large site that we have, the Pentagon, has over 13,000 of these RS-45 devices that now are being converted over to IP. That brings with it all the complications, but it also brings with it newer ring technologies that allow a ring manager switch to secure what's below it and yet still provide complete visibility through the ring into each device on the ring. So we can actually implement more things using IP than we could in the past. But with it comes the need to, as Barney brought up, have it pen tested, and you have a certain level that's acceptable, and those are the products that you're allowed to put on the job site.
Yeah, I do have a follow-on question. So again, as sort of wearing my Google hat, I totally agree with Joseph's observation that as far as sort of updating software or firmware on the IT equipment, we have that down pat. But the sort of processes in place for updating firmware, for example, on an HVAC device, that seems to be very ad hoc. So are folks such as Johnson Controls and Schneider, for that matter, also investing in sort of the deployment pipelines themselves, where you could have, in theory, a repository which is remote, where there are trusted packages being essentially hosted, and that allows a direct sort of pipeline into customer equipment? Is that a direction that might be interesting for sort of further investigation?
I'll let Barney go first again there.
Yeah, that would make me very nervous if I was in your position or Steve's position, to think that a device could reach out onto the web and grab a piece of new firmware and all of a sudden start using it. I think that historically, it is up to the end user to determine how they deploy and why they deploy updated firmware.
Understood. Joseph, any points of view there?
So I would echo that. While our operating systems in our network level controllers and our field controllers, anything that's IP, are evolving to the point where they could handle an automatic update without human intervention. As someone who used to run facilities, if I'm running the chiller that's taking care of a critical facility, I'd still want a human there to make sure. And the other things that Barney brought up, make sure you test it out on a redundant side of things or on a test bed before you do it. But for other applications, an office building or a K through 12 school that maybe isn't so critical, that's something that you're going to see over the next 12 to 18 months maximum. You're going to see that manufacturers will set up subscription agreements so that automagically, as I call it, they would send to the server, here's the latest updates. The server would say, thank you. Yep, I've got a subscription. And then at 3:30 in the morning or whenever it's set up to do it, it would go out and patch the devices out there. That's something that will be available, but I can't see it in the near future for data centers.
Understood.
And to echo what Barney mentioned, it would freak me out, frankly, to have this happen without that human intervention, without the validation, and just thinking that really kind of violates the principles of network segmentation and something like the Purdue model, where these devices are supposed to be as far from the internet as possible. Yeah, it would be a huge security concern, obviously.
Great, thanks for that point of view. So sort of moving on to data export as well as formats. It does take a non-trivial lift to actually deploy and commission a monitoring system in a facility. So those of us who've kind of gone through commissioning facilities sort of know this, and it tends to be almost like a bespoke thing on a per facility basis. It's not like, essentially, booting up a computer with Linux or whatever and then doing it like 250,000 times repeatedly. This is quite different. But that being said, would it actually make sense to at least standardize data payloads from different vendors to monitoring systems so that the bring up of these systems becomes somewhat easier? And it also allows customers such as ourselves and Facebook to kind of make use of the data in a much more, shall we say, seamless format. So I'm just sort of curious to hear how Facebook thinks about it and whether JCI and Schneider are kind of thinking along the same lines as well.
Yeah, and kind of like the protocol discussion, simpler, unified from our perspective is better, and ensuring that it includes some of the security concerns or, security logging events that we might expect consistently. So, you see a new MAC address on the network, or if it has authentication mechanisms, that making sure that that's logged and in a standard format would sure make it a lot easier for us to monitor these systems. Joe, what's your take on that, and what direction might you be heading?
Yeah, there's a couple things to touch on here, and we've actually had it where some of these large customers are saying, we want direct access to every point on your system so that we can pull the data out and do our thing with it. And obviously we have APIs that allow you to do that, and they go through the same HTTPS and the same security that our normal communications. But there's a concern too in terms of how they're going to use that data and who's using it. I mean, if we're talking about the actual temperature and operation of the server machines and some of those components, that's one thing. But if we're talking about the chillers and the HVAC equipment, frankly, I hesitate to say that we probably know HVAC better than most of the data center people. And we can give you that data and expose it, but that also violates your connection there if we're going to expose that data. And all that being said, in our industry, there's actually some semantic tagging metadata type formats that are becoming standards and are competing standards. And this data is set up so that I can pull information out of a space, and then it has a relational database structure behind it saying, this is an office, this is a meeting room in an office with an exterior wall with 2 windows facing the south. You can actually define spaces and then the related equipment. From there, you can make some comparisons, you can make control logic and do a lot of things with it. So that new semantic tagging, one of them is called Project Haystack. And there's a very strong focus there on the equipment to equipment relationship. Another one, which is somewhat more of an academic, but it's gaining a lot of popularity, is called BRIC. And BRIC takes BIM as well as the physical space and the equipment relationships between each other and how they work together. So when you start talking about alarming, you can build some very smart alarms saying, if this chiller can't deliver enough chilled water to the air handling unit, I don't need to have an alarm from the air handling unit, an alarm from 20 boxes out there, because I already know what the problem is. And doing other fault detection diagnostics becomes very handy. ASHRAE itself as an organization is taking those 2 main semantic tagging schemas and looking to homogenize them or unify them under something called the ASHRAE 223P, which is probably 18, maybe at the most 24 months out before that becomes an ASHRAE standard. So there's a lot going on out there for the data management side of things, but it conflicts again with the idea that, am I going to export it out of the building, establishing a connection with the outside world?
Barney, any thoughts on the electrical industry?
Yeah, so again, there's 2 perspectives. There's one that, I'm deploying a new data center, or I'm upgrading a data center on one every 6 months or every 12 months. There's completely different than I'm going through an IST every 6 days for the next 4 years. And in order to be that scalable and to be able to react that quickly, certainly point naming and that activity and is critical. A lot of time has been put into that on the current project, and it was based on the IS-88 model, such that everyone that's consuming data, when they read a point over OPC UA, they know what that point is, and those points have been defined and put into a box. Certainly within the controllers, we've got thousands and thousands of tags that are available, all the way down to individual out of tolerance, out of range sensor information. And in order to meet the specification requirements of generally a 1-second update rate on the graphic user interface that the operators use in these buildings, you have to restrict the data. Yes, there's all this data there, but getting it would certainly put you over the 1-second refresh rate that you're required to accommodate. And when we're doing that in the PLC side, we're doing it with a 20 millisecond scan rate. So information overload or data providing overload is certainly not something that you just want to do, because not only the other point, you're exposing potentially hazardous, I would call it, data onto the network, something that could be used against you in terms of functional behavior. You really want to restrict that. So yeah, that's my response to that.
Got it. So it does sound like there are, at least in the HVAC space, there are certain efforts that ASHRAE is leading to kind of harmonize data export from different classes of equipment. So we have about 5 to 6 minutes for questions. I just want to make sure that there's sufficient time to answer any audience questions, if there are any. So there's a comment from Monty Weissman about there's basically an observation that it's not really about preserving the confidentiality of the information, and it's really more about source authentication and integration for security. It seems like a reasonable observation. Do folks have a different point of view on this?
And I'm not quite sure I captured that.
Yeah.
So I'll just read the comment out. Encryption prevents packet inspection. What is really most often needed is source authentication and integrity, not confidentiality.
This is Monty. I don't know what the protocol is. We're allowed to cut in with questions verbally.
Go for it.
Okay, thanks. I asked the question. Yeah, oftentimes people just say we're just going to encrypt everything to protect it. And my observation is, especially when you're moving packets around, especially from OT to the IT side, and I think the encryption, as someone observed, to figure out which one of you, is the certificate management is very, very difficult. And you don't need to do that if all you've done is integrity protected and provided source authentication, which is kind of done using the same mechanism, that is to say, digitally signing. The only one that really cares is someone wants to verify the information at the end. So it was just really an observation that people throw around, we're just going to TLS everything is protected. And I think in this in industrial scenario, that's overkill.
And great observation, Monty. And I'm not sure if you caught it, but I mentioned I had to rethink how I thought about the different needs of the different systems, and had actually shifted, removing confidentiality from the CIA triangle for IT systems and inserting safety instead of confidentiality, because that's really more primary concern with these types of systems.
Yeah, I mean, it sounds like you have. Like I made that comment. I posted that comment before you made your statement.
Okay.
So you and I are. I think you and I are in complete agreement.
Yeah.
So.
Sorry, Barney. I had a quick question based on something you said about like the threshold levels that might be identified. That's actually been a topic of discussion here at Facebook. How do we classify that? Are thresholds considered sensitive data or not?
So I'm not sure that the thresholds are there, but you just have to pick and choose. There's a balance between I want X amount of data in 1 second, or I want 10 times X in 1 second. you can't always get 10 times X in the same amount of time. And the other thing is you don't want to overwhelm operations people with too many options. That guy that's there at 3 a.m. in the morning dealing with a thunderstorm has got enough on his plate. And I would also add a supporting comment back. Certainly alert remediation is a critical piece of the design. Again, not to overwhelm that operator at 3 a.m. in the morning.
Yeah, I'd go along with the data glut comment there that Barney had. There's just so much information. Just one VAV box has 10 different points of information. So if you have 100 of those before you even touch the chillers, you've got data overload. In terms of authenticating where that data is coming from, and is it authentic, I think that goes back to the built-in protocols, BACnet, and how it delivers data, and then the protection of who's allowed into the system and permissions. So can I insert or get into the middle of the stream and change it and turn off a large chiller, so all of a sudden the data center overheats, or the ventilation system closes down and doesn't provide adequate cooling. I think that kind of protection still goes back to how the system is set up and the protections that are built into the system, more than just swapping the data out. But it's a good thing for me to start thinking about.
Great. I don't know if there are any further questions. Doesn't look like it. We are right at 10:15, which is when I believe we were supposed to wrap up. So I just sort of want to again make the comment that we are in the process of essentially trying to bootstrap an effort around security and monitoring. And I'll sort of leave the audience with a comment that please stay tuned for further updates. We're trying to harmonize this effort across other efforts within OCP, but we should have some updates pretty soon. So with that, thank you so much for your participation, Barney, Joseph, and Steve, and really look forward to kind of working on these topics in the future.
It was great. It was educational for us too. Yep. Thank you.
Thank you, everyone. Bye.
Bye-bye.
Thank you.